free pizza and beer right over here. Free pizza and beer. Unlimited free beer. All right. Well, people will come and straggle in. Jan, do you want to? I'll kick it off here. Okay, so my name's John Masters, and I'm Chief ARM Architect at Red Hat. I'm going to lose this hat because I kind of am in the cool dude mode here. So, and what we're doing today is we're talking about ARM servers, myth or reality, hopefully more of a reality than a myth. I'd like to go ahead and introduce the panelists today, so we'll take it with Zach, and we'll work the way down the line here. So, Zach, do you want to go ahead and introduce yourself?
Sure. Hi, my name is Zachary Smith. I'm the CEO and co-founder of a company called Packet, and we automate fundamental single-tenant bare metal compute for about 8,000 developers from our 4 global locations. We do that for both x86 and ARM.
Elsie?
Hi, my name is Elsie Wallig, and I'm a director in the product management office of Qualcomm Data Center Technologies. We build ARM servers, and that's my focus.
Hi, I'm Larry Wikilius. I'm Vice President of Software Ecosystems and Solutions at Cavium. And among many things, Cavium is a silicon company that is delivering ThunderX, which is our ARM-based servers, and that's what we'll be talking about today.
And I'm Jeff Underhill. I'm the Director of Open Source Enablement at ARM. So our technology is at the foundation of a lot of the products that we're hearing about here today.
Martin Statler. I'm with Lenaro. We focus on open source collaborative engineering for the ARM. So I've got the data center. That's why I'm part of this group, and quite a few here sitting are members.
And I'm Jan Fischer. I'm with Red Hat in the product marketing capacity, responsible for our alternative architectures, ARM and others, and also hyperscale computing.
Great. So now you've heard we've got a good panel today of some very esteemed friends in the industry. Now, I'm going to go ahead and ask some opening questions here that are very softball and very nice to everybody. No, I'm going to ask some serious questions. And I want you to think about if you have one or two, and as we get further in, we'll open it up. So I'm going to go ahead and pick on you, Zach. You've been through the experience of acquiring and deploying real ARM servers into production. So I want to ask, can you walk through some of the good experiences you've had as well as the areas for improvement? And how do you think this translates into whether ARM servers are a myth or a reality today?
Okay, so does anybody here actually deploy workload on ARM servers today? Does anybody want to? Okay, cool.
This is good.
So we're at the right place. So my journey with ARM servers, I've been in the hosting cloud business for about 16 years, which means I've bought a lot of hardware. I bought a lot of Intel, I've bought a lot of AMD, and most recently I set out to buy ARM servers. And it is not as easy as buying x86 or other things, right? And what we found out was that it's certainly a reality. It can be done. It is not going to be done through your local CDW rep or your Ingram Micro distributor at this point, but I feel that that will soon come. What we have found is the maturation of the overall platforms. The ODMs and certain OEMs are certainly conversant. They make systems. There are systems available. They generally boot. You can make them work. And so we found that the process has been, I would say, at both times very frustrating and almost cathartic at the same time, right?
Does it matter, by the way, that you can't get a system from CDW? Does that even matter in the world we're going into?
For us as a cloud service provider, it absolutely doesn't matter, right? So we work at a scale where it's sufficient to work with an OEM or an ODM. And because of that, we don't actually want to work through a kind of reseller or VAR. However, at this point, the technical engagement with the actual manufacturer is a value add. So, when we're trying to make all the stuff work that we'll talk about later, I've gotten to know most of this panel, and it has taken a decent amount of elbow grease to get these things through. But as a cloud provider, frankly, we don't need to work through a CDW.
Right. Okay. Okay. I'm going to open up a little bit more here. Not everyone here deploys ARM servers. Some of you build silicon. Some of you are involved in the broader ecosystem. But if you want to pass the mic down, Zach, to anyone else who'd like to, Elsie, would you like to add a comment on kind of the experience? Are they a myth today? Or are they a reality? What do you think?
Well, I think it's very much a reality in terms of building the ARM servers. What we do is we build server chips, and in adopting all the standards-based initiatives that have led us to this point, I think we're well positioned to make ARM servers a real reality.
Anyone else want to add a comment? Larry?
I think the other thing I'll add is it's been a journey for a number of the folks up here and companies involved in this space where over the last few years we've built up a thriving ecosystem that enables customers like Zach to now more easily deploy, or end users now to take advantage of some of the differentiation you see in these platforms. So it hasn't happened overnight, but we've driven that, whether it be open source or commercial enablement, to a point now where the flywheel's going in a positive direction. And that's critical for the user base as well as the partner base.
Yeah, Jeff, everyone gets to say something.
I'll just add, I think it's a little bit of both, right? So there's some reality that we're seeing now. I think any of the myth is more misconception. To Zach's point, you can't just go buy these things at Fry, CDW, and as a result, I think that leads people to think, well, I keep hearing about this stuff, but where can I get it? The reality is there's a ton of stuff going on under the covers with the big guys who are very capable of ingesting this technology, very self-sufficient to be able to figure it out and deploy it. And then, it becomes a broader reality over time as we mature that, as the ecosystem builds out, as people have, a broader set of workloads that run on them. So it's absolutely a little bit of both. We've got to address some of those misconceptions and make sure that people understand exactly where we are in this journey. It's a marathon, not a sprint, but we are well on that path and heading in the right direction.
Okay. Well, actually, I've got another question. I can build on that and put you on the spot. So I'm going to come on to ecosystem, depending on which country you're in, and how we build that out, right? So, but I wanted just to build on the how people consume this technology, because some of us had breakfast this morning. We were talking about, in the industry, there are certain conceptions about how you consume technology, right? So that CDW model, that going and buying a server, and I think there's been a lot of interest in the big public cloud vendors. So I'm going to ask you to answer that in a second, how you see the people consuming the technology. But since you have a key role in ecosystem development, I want to ask, how do you think having one-click access to the technology changes things? And what else do you think we need to do from an ecosystem perspective?
Okay. Yeah, so there's a couple of things here. One, of course, is the general availability. We talked about Fry, CDW, etc. There's multiple tiers. So there's a lot of people at the maker level doing all kinds of weird and wonderful stuff on ARM just because they can with Raspberry Pis, Odroids. I mean, a number of times we're at these events and we talk to people and, like I'm running, distributed storage solutions on this kind of stuff. Lenovo has 96 boards and other things available, all the way through to real big iron servers from Cavium, Qualcomm. But from a community standpoint, having access to that is kind of fundamental. I've engaged with some communities. They're very willing. They have a strong desire to support the ARM architecture. It's just you got to remove that friction from the from their, make it easy for them. It's like, we want to do this if only we could. So don't slow them down. Don't put things in the way. And that's where companies like Packet come in. They're doing a really good job of seeding systems, enabling the developer community, scratching that itch, if you will, and saying, okay, guys, we know you've got a strong desire to do this. We want to help you do that. And we just got to do more of that. We're at the start of that journey. It's really starting to gain some momentum. We just got to put some more fuel on that fire and really start scaling those efforts.
Okay, Martin, do you want to add any comments on how you see people getting access to machines as a driver?
All right. So first of all, anybody interested in open source? Couple? Okay. All right. So the big thing about an open source project a lot of times is it starts off as a project. That doesn't mean there's a company behind it. It means that there's probably no... It's easy for you to start and work on open source projects for x86, right? What's challenging...
I've heard of it.
Yeah. What's challenging is when you, to your point, you're really excited about doing that, and there's no place for you to go and get it. So we have Packet now coming in and doing quite a bit. Lenaro, which is this organization that gets collaboration of open source software development, we've had the server cluster that ARM has funded, and that's working well. And we also have a developer cloud. Now, I'm a non-profit, so I don't have hundreds of systems, but we have developer clouds, and we have that in Shanghai and the U.S. and in the United Kingdom. And then we have this focus on 96 boards where you can get something the size of a credit card. We're working on bigger workstation offerings that you can have, but the idea is how do we get open source developers access to the ARM server ecosystem, right?
Very good. Okay, I want to pivot slightly here and talk about workload acceleration a little bit. So, at risk of sounding very, very trite, we live in a great time of change, right? So while some of you were early proponents of workload acceleration, and I think one of the themes that we had in our breakfast chat this morning was that the realities of the data center are changing. We had a lot of workloads in the past, hundreds of workloads, and I think what we said over breakfast was that we're now at a point where you may have 1 million or 2 million machines really focused on 1 or 2 key workloads, and acceleration is a key part of that play today. I want to pick on you, Larry, first. Maybe you'd like to just talk a little bit about how you see workload acceleration changing the landscape.
Yeah, I think, we talked about the ecosystem, and that's good, but ultimately, customers are going to say, so what, right? What is it that I'm going to get out of this architecture? And one of the things Cavium's done is talked about workload optimized processors. And what do we mean by that? Well, to John's point, you have a certain number of critical applications that if you really understand the architecture of the application and the use case, there's things you can do at a silicon level to improve fundamental performance, cost, and cost of operation for those applications. And that's what you're seeing coming out of this architecture. ARM enables that by the model of the architecture itself. Companies like Cavium who have delivered acceleration in areas of security, network offload, compression, those are critical elements to a lot of the major applications in today's data center. And that starts to spur innovation and capability further up the stack that maybe you can't do today with the volume server that's sitting in your data center. And that's really what this wave is all about. And you're going to continue to see more and more innovation there. And that innovation can happen at a silicon level and abstract it away ultimately from some of the user level so you don't even have to worry about it. And there's sort of, then the magic happens, right? But that's what really excites, I think, the industry and excites especially some of the innovators that are using and deploying this technology today.
Yeah, okay, great. And Zach and Elsie, I'd like you to get, Zach, go ahead.
So I just wanted to add something on that earlier. When we, if you guys haven't been to Packet.net, we deploy servers for people, we deploy Intel and ARM, they work the same.
How quickly could I get a server if I go on the Packet.net right now?
8 minutes, right? So
right.
8 minutes, bare metal compute, ARM or Intel. What we worked on was a user experience and access that it had to be as good as the experience you have on Intel. It should just work. It should work with your common operating systems, which we can talk about in a second. The developer access experience for a sysadmin or an end user shouldn't differ, right? That's just table stakes for access, right? But I think what's really interesting about the kind of idea of specialization that Larry's getting towards is that workload optimized, silicon offload, specialty hardware, right? We're getting into a place where why do I care about Intel or ARM? What does it matter for me? It has to be what? 10 times cheaper or 10 times faster for me to really care about this work. Or maybe it's even more. Maybe it's 100 times cheaper, 100 times faster. Go either way. And what we found is we offer, by the way, Cavium cores at 10 times cheaper than E5 cores on our system. So people like it for that very basic reason. But the place that this is going to get both challenging for the ARM ecosystem and really interesting for the ARM ecosystem is the Qualcomm chip is totally different than the Cavium chip, is totally different than the Applied Micro chip. They have different specialties. They use the same architecture, which is where Linaro's come in and helped make that foundational access. Like Red Hat will boot and things will run, but they'll have offloads that will be very different, and they'll have unique kind of architectural differences. And frankly, I think it's going to get beyond the capability of individual developers or sysadmins to choose that and say, well, which server do I run what workload on that will be optimized for this thing? You could say the same thing with a GPU or an FPGA or an IPU or something like that. This is where smart software comes in my opinion. So I think helping, optimize for software, or those ecosystems is really critical. So how about Red Hat?
That's certainly how we see our strategy. Jan, do you want to talk all about the wonderful things that Red Hat's doing today? Just to put you on the spot.
Yeah, sure. Well, I think a couple of reflections of what had been said. It is an ecosystem, and in ecosystem, we use the word very often, but it actually does come from Mother Nature, right? So there are dependencies, there is variety. The variety is the fundamental success factor in any ecosystem. So to have the offering, the innovative things on silicon is critical to success. Then there are dependencies, there are symbiotic relations. You could say, you could go through the whole list of attributes, and it all be applicable to what we're trying to do. But it does take a village to build an ecosystem. It takes, years and years to actually grow this, to actually stabilize it and work on it. So Red Hat's been at this journey for over 5 years now.
6.
Yeah, 6 years, starting with, John, actually. So hats off to you for kicking off that effort. But the idea for Red Hat there is to create that unified glue, the layer that will join all these different innovative platforms, different pieces of silicon, and present this as a unified view to an end user. So from your perspective, it's all going to look nice, usable, and consistent. So that's exactly our value add in this scenario. And just the sheer fact that we're sitting here at the Red Hat Summit with the representatives from all these great companies talking to us, and we are all literally friends working with each other on a daily basis, I think that is the value that Red Hat has, and our ability to build communities as such have been proven time and again, and we're going to do the same thing for ARM.
Very good. I want to give Elsie a chance to answer about the workload optimization and the changing landscape and how you see that playing out for Qualcomm as well.
Well, I think the data center is primed for re-architecture, and that includes the adoption and inclusion of heterogeneous computing. We see there's evidence of it already today. It's been adopted, and I believe that standards will continue to make that accessible by all. And that's where Qualcomm is focusing its efforts, so that when the ARM servers play in the data center side by side with all of the other systems, it's a seamless experience. And standards will make that possible, whether your compute is a general purpose CPU, whether it's an FPGA, and whatever your acronym of letters for compute is, it'll be seamless. And that's what standards brings us.
Very good. I'm going to let you keep the mic. I've got one follow-on question. So there's a lot of talk in the industry, certainly in recent times, about the demise of Moore's Law, which is a famous statement from one of the co-founders of Intel, Gordon Moore, where he said that effectively the compute power, the density of a chip would okay, I know you're shaking your head. Okay, the density factor of chips would change in such a way that every couple of years you'd get this order of magnitude and an improvement. And we're seeing change here, where people are saying, look, Moore's Law is dead. It's dying. It's no longer relevant. What do you think?
What do I think about that? Okay, good question, John. So while there's certainly evidence that Moore's Law is slowing down, dying, whatever your words may be about that, I like to think of the progress and change and innovation that is happening today that we're also seeing driving new innovations, fielding this industry. Where the center of gravity for innovations in the past has been focused around the PC and semiconductor process nodes stemming from the PC industry. These days, there's 3 times the number of smartphones sold than a PC. And that's where Qualcomm's focus is. As a market leader in the mobile world, we're committed to...
I've heard of you guys, that's right, yeah.
Yes, to bringing our server technology to the same space. And so the server chips that we're already sampling and will be out by the end of the year and commercially available will be built also on 10 nanometer technology. We're the first world's server chip that is based on that innovation. And I believe that innovation will help fuel the void that is being left by the change in Moore's Law.
Very good. Larry, do you want to add anything to where you see Moore's Law going?
No, I
Does it
think
matter?
Elsie covered it really well. I think just the fact that the impact of what you can do as things start to level, as Moore's Law slows down. And the other thing that Elsie touched on that I think is really important is if you look historically in the server space, innovation hasn't really come top down, it's come from bottom up, right? Killer workstations killed the vector machines, PC it created x86, and now we're seeing mobile with the ARM innovation. So it's a fascinating history going back really 60 years. And this is the next wave, and this is the leverage that we get from the infrastructure and the commoditization that happens as you think about silicon and where servers are going.
Do we ever get to a point where it's so boring it doesn't matter anymore?
We're here to make it exciting. Come on. Look, this is something we talked about at breakfast. You talk about innovation and you sit around and you think, could you have predicted 5 years ago what's happening today relative to self-driving cars and some of those elements? You've got the 5G infrastructure coming. That creates the opportunity for innovation that we can't necessarily even imagine right now. And that's the cool part about what's happening here.
Yeah.
So boring, yes, on just a basic enablement, absolutely. But then getting out of the way for the next generation and others smarter than us to go do that.
Okay. Yeah, Zach, go ahead.
I mean, we touch around 8,000 customers on our platform who access and build and innovate on what is essentially boring compute, right? They take servers and they do great things, right? What we're constantly impressed by, and Ed here, who runs our community projects for the Works on ARM website that we roll, we touch a lot of people who are building things that, frankly, a year ago I wouldn't have thought possible. And they're talking in terms of compute capacity or in terms of data capacity for applications that right now seem really, really out there, right? And I'm talking about my 5-year-old won't drive a car, and how's that going to work? Is it going to work in the same methods that we use today, or are we going to innovate on the whole stack? I think we're probably going to innovate on the whole stack, because when I was coming from Logan, the GPS didn't work 2 or 3 times, and we got lost in the tunnel twice. I hope that we improve that. I hope that we improve this by an order of magnitude, not by 10% every 2 years, which is kind of currently what we're at. And so as a consumer of the silicon, we're excited to see what our customers can do with it, but we're also interested for the competition that is going to happen, right? I'm excited for all of you to compete for our business, as well as Intel, as well as anybody else who can come to the market with an architecture.
So it's the server Hunger Games.
Yeah, I think we need it. and yeah.
Excellent. Awesome. Okay, so Jeff, I want to pass it down to you. So ARM recently announced an investment in standardization, significant one, and new tools to kind of validate. So we're all kind of building things that inherit from your fundamental architecture and then innovating around that. So what more do you think needs to be done there, and kind of where do you see we are today?
Yeah, so I guess as the owners and stewards of the architecture, it's kind of our role to help corral the partnership and make sure that that's a collaborative development environment. I wanted to touch on this earlier, so I'm glad we came back to it, because we're talking about workload acceleration here and unique chip capabilities. The key point there was abstracting that away such that software doesn't have to care about it ultimately. One of the things that we're really keen on is ensuring that our architecture remains software consistent across all of these platforms, right? The last thing we want people to walk away from here is like, great, there's a bunch of snowflakes, and that's just going to be a pain because now I got to code to 8 different varieties instead of 1 or 2, and that's absolutely not the case. And this is why standards are really important to making this technology accessible to people. So at a platform level, abstracting away a lot of the underpinnings just got to happen. We're way down that path now, where the OSs just drop on. We use UEFI, ACPI standard mechanisms to abstract that away. As we get to future versions of chips with more accelerators and things like that, programmer productivity is really the key now, right? So people are trying to innovate so fast, leveraging open source projects in weird and wonderful combinations that make sense to them, extending them, forking them. It's a fast-paced world. Somebody, I think, mentioned it earlier. We just got to get out of their way and let them do that innovation, empower them, but let's not make it complicated, and you have to understand all the bit twiddling. So standards are paramount to this. We knew this. We started standardization specs 5 years ago, maybe more. SBSA, which is a server-based system architecture, and SBBR, which are boot requirement documents that help explain to everybody how we abstract this stuff away. We need similar things for these accelerators. Zach, you alluded to it earlier with how people are going to manage this infrastructure. You just got to have these smart software that auto-scale and know where to run the right thing at the right time. Compute's moving through the network to the edge. I mean, this is a fast-paced, dynamic environment, and the ultimate nirvana is that as a programmer, I don't care. My app knows where to run best, whether it's close to the data or away from the data. It knows which accelerators are available in its purview throughout the network. It runs in the right place. It auto-heals, it auto-scales. I mean, all this stuff is becoming a reality, and that's where we got to get, because the scale of these applications, the magnitude of the data that they've got to ingest and make decisions on is growing intensely, and there's just no way we can accommodate that in the absence of all of these things happening. So
very good answer. One last question for you, then I'm going to open it up for a question from the audience. Jeff, if you hold the mic there. Microsoft recently announced their endorsement of ARM Server. They're a good partner of Red Hat. We like working with Microsoft in the industry. And they announced that the importance of ARM Server standardization, which builds on the previous question. Do you think that their announcement makes it easier for those in the market who are kind of on the fence, both from the consumer side and then also from the other broader, bigger players in the industry?
I mean, the short answer is absolutely. And there's a couple of facets to that, right? So one of the largest cloud players in the world have made a public statement about their internal evaluation of ARM. I think there was a statement that greater than 50% of their workloads they found to be applicable on ARM. That's a huge amount. They buy an awful lot of servers. Two, the standardization effort that we started years ago that I kind of just spoke of is fundamental to enabling multiple operating systems to just deploy on these and be seamless and boring in that respect. So yeah, I think it's absolutely a huge credibility statement. I alluded to it earlier. There's been a lot of things going on under the covers, not so many people talking publicly. So it's great to see Microsoft come out, make that step. It wasn't just about them evaluating ARM too. There was OCP platforms. It was at the Open Compute event where this got announced. They have OCP platforms already based on ARM from both vendors, right? So this is a reality. So back to your opening and the title of the talk, right? Myth, reality. There's a great example of some very real activities. Yeah.
Does anybody else want to kind of build on that? Maybe Elsie wants to add a statement on it?
Yeah, I'd love to add to that. So OCP is a great project, and Microsoft's endorsement through OCP or the Open Compute project that is really a testament to where this area is going. The project is called Mount Olympus, and one of the things that Qualcomm did was we submitted a platform that can be used as a building block for other data centers and anyone to adopt an ARM platform as well.
Okay, I'm going to open up to questions in a second. I want to just build on that one thing. Maybe Zach, you've got a comment there on how you see Open Compute changing this as well. How does that play into how you consume hardware today?
I mean, Open Compute, Rack 19, whatever, standardize it so OEMs can make more stuff that I can buy is fine, right? Personally, I don't think that that's really good to build volume, and volume is an interesting kind of concept within this world.
Yep.
It's kind of hard to get the flywheel moving because it takes some real money to turn up, board manufacturing, and for us to go and ask for a board from an ODM independently is rather difficult. But for everybody to say, let's all make another board is good, right? So I think the nice way about that, what Qualcomm's done and Microsoft, is they're doing it in a fashion that other people can reuse, right? It's open, and other ODMs can use this to create boards that also reference this. So I think that's a really great.
Cool. Yeah, and it's great to see both Qualcomm and Cavium having designs there, and I think there's some actually on the show floor. So I'm going to open up to a question from the audience. If I'm going to get you to call your question out, and I will repeat it. So let's go with you first. You had your hand up. Yeah.
Yeah, so we talked about Moore's Law ending and acceleration, but but software is eating the world, so we're going to need more compute. And the strength of ARM historically has been low power, multi-core variability, shutting down. But the initial server chips are not low power in the server. So I'm curious what the roadmap there is, where increasing density so we can basically scale up.
That's kind of cool. It's almost like he's read my question sheet. I had one on, we had a density play. Thank you. We had a density play originally, and then we went to kind of brawny solutions. So who wants to grab that first? Martin, do you want to add a statement on that?
So I'm going to hand it over to the Silicon guys in a second. But the thing about it is that roadmap, the advantage of ARM is that there's not one single roadmap, right? There's many different SoC vendors who are in the market, and they have their roadmaps. So there is an SoC that's just come out, and they have low power ARM systems, and the cores up to 1,500. So they're doing a different approach of how they're going to actually attack that market space, and that's different from what Cavium is going to do and what Qualcomm's going to do. But that's where you're going to get all this variety. So instead of having a horse, you've got a zoo where you get to pick what animal it is that you want.
Okay, so let's let you guys get a word. Jeff.
So I just have one comment. So fundamentally, everybody's battling physics, right? I mean, that's we're all up against that. So the thing is to give everybody the right knobs to turn in the right direction, right? Do I need high throughput? Do I need high single-threaded performance? Do I need massive memory capacity? Do I need massive I/O? And that's part of the beauty of the ARM architecture. We do not mandate that to anybody. We have an architecture, we have an instruction set, we have a bunch of component parts that you can choose to build from or not. And that's where we give the flexibility to vendors to, like Martin said, decide on their roadmap. Am I going all the way up and to the right? Am I looking for a broad swath mainstream? Is it an absolute density play? Am I going to be scavenging cycles to get electricity because I'm in some remote location? We don't care. Whichever you want, right? We give you the ingredients. You put them in the combination you need. That said, if you need lots of memory channels, then that's a lot of wires right now, and so there's electricity involved. If you need huge memory capacity, so there's still some variables that we have, but there's also physical boundaries that everybody's working to address over time too. So
the one thing I'll add is going back to your question. The breakthrough really over the last, let's say, 12 months or so, at the baseline, single-thread performance on ARM servers is at a point to meet requirements for the broad set of the market. Fundamentally, Jeff mentioned the Microsoft announcement, being able to satisfy that level of Azure workload. You now are at a building block point where we weren't 5 years ago, 7 years ago as we started this. So you have that base, and then you can pivot, right? Do I want to pivot such that I want more density of cores? Do I want to pivot such that there's certain acceleration and optimization I want to build in? You're seeing that in the vendors. You're seeing that even just from a Cavium perspective, we'll go from 2 to 96 cores depending upon product line and segment. Am I targeting more of an NFV type market, or am I targeting more of an HPC market? So I've got that as a building block, but then at a software level, I'm running the same kernel. I've got the same drivers. I've got that commonality. So from an investment standpoint, it's a huge leverage for us as a silicon company, for our system partners, for our OS partners. So these are pieces that have come together over time, and now I've got legitimate choices to really make with very low trade-off or lock-in as well.
Elsie, you want to add a comment?
Yes, certainly. So density and system architecture of the server you buy is going to be based on what is your data center need. So in some cases, you're going to need a more dense data center. In some cases, you're going to need some acceleration. And those are the choices that you'll be able to make, but the ARM ecosystem is the one that's going to fuel that spectrum. You're going to look at what's your cost, your power, your performance needs, and that'll yield whether you purchase or you go for specific densities.
I think one comment I would add is that it's always a challenge when you move from a traditional market like a mobile play that ARM traditionally was into the server space, and to Jeff's point, we certainly see this sort of bifurcation where you're going to have mobile class parts that will always be for mobile, and you're going to have server class parts, and they are different. So it's going to be very interesting to see what the diversity brings over time. You had a question, sir. Actually, the guy at the back had a question first, and I'm going to come back to you after. Okay, go ahead.
This really is more of a statement, which I think can add here. I don't want to sound like a plug, so I won't tell you who I am, but we're a strong Cavium partner. And if you have a Cavium server, it might have come from a company called Gigabyte, which you probably know makes x86 motherboards and graphics, but they also have a server business unit. And we're also a partner with Gigabyte, helping get these servers to market. So in fact, if you want to buy a server from CDW, you can. Chances are that we're going to touch it, and we're going to make sure that that machine boots before it gets into your hands. So we're working with ARM in the infrastructure, trying to make that happen, to make it easier to get access to these servers. We have servers in stock. If you go to the Gigabyte website, look at their distributors. You can call one of their distributors, and we'll get involved with it in that process. And we can get right to Cavium if you need help, or get right to Red Hat. So we're working in this Tier 2 and Tier 3 space. You don't have to go to the esteemed folks here up on the panel, and you can find us in the ARM booth.
Thank you very much. And Cool Now operators are standing by. You had a question, sir.
Yeah, there's quite a bit of tension in the air at the moment between the monolithic application development environment and its future hosting and microservice architecture deployment. Is there something beyond microservices, and does ARM have a special message there?
Good question. Who wants to grab that? Microservice? All right, we'll come back to you.
Did you say microservers or
services? I think
services.
Services.
Yeah, nano services. They just keep getting smaller and more, right? No, but all joking aside, that's really where things are going. People are decomposing these problems into suitably consumable pieces. Amazon Lambda Services is a perfect example where people don't care what this thing's running in. Maybe they care what it's written in, but at the end of the day, they've got these little building blocks that are granular enough, functional enough, and then they get to assemble them in weird and wonderful combinations that meet their needs. That's where we're heading. The monolithic piece of that too, I mean, we saw a great example in Red Hat's keynote yesterday, and I may get this wrong, sorry, Red Hat product manager, but the JBoss Enterprise Application Platform, right? EAP, there was the application...
He's well trained.
Toolkit. Huh?
He's well trained.
Yeah, application migration toolkit, right? It's like, take your Java monolithic application, we will help you transition that to a modern, open, scalable environment. There's things like that that exist. So it's absolutely going that way. That lends itself to the ARM architecture and some of these solutions extremely well. One of the questions that we had before, somebody was asking about traditional enterprise and ARM's role there, and when they asked me this, I kind of posed the problem back almost and said, hey, what is traditional enterprise anymore? Because everybody's looking to modernize their IT. And for us, it doesn't make any sense to try and look in the rearview mirror and intercept monolithic legacy applications from years ago, because they're kind of going away anyway. We're riding this open source wave, this transition to microservices and scale out, cloud native, public, private, hybrid. I mean, there's just so many dynamics at play here, allowing people to scale and implement new solutions. And that's part of the vehicle that allows us as a new architecture to even enter this space. So, yeah.
Very good. And
Did
then
I answer your question? I'm sorry, I got a lot of stuff there, but does that help? How do you build a nanoservice? You take a microservice and break it into about 50 more pieces.
All right, Zach, I'm going to let you add a word here.
And sorry, one thing before we move on. The gentleman that was talking about servers being available never mentioned his affiliation. So Phoenix is the distributor, and it's with a CS at the end. Phoenix ICS, not Phoenix, the BIOS company. So.
So does anybody here develop or work within the Docker community, or so? Okay. So did you guys see Docker? Were any of you at DockerCon or watched the keynote last 2 weeks ago in Austin? So if you weren't there, they basically announced something called Moby and Linux Kit, which is essentially building let's call it a developer-friendly unikernel. Okay. And it's basically Linux primitives that you can build and consolidate a specific function into that, instead of including, say, Docker plus a generic Ubuntu container that includes everything plus a bunch of layers. What's interesting about that, the Docker team developed that on Packet, and it is multi-arch capable from the beginning. It works on both ARM and x86. It doesn't care. And I think that that's really an important part of when you think forward about where these things go. It's all about net new workload, in my opinion. I actually don't care whether it's x86 or ARM. Most workload in 5 years is going to be new versus like new from today on. Right? I think more workload is going to get created from today forward than past, right? And so I think that's one good example. Followed by DockerCon was serverless. I think serverless conference or something like that, where another customer of ours showcased functions as a service FAS platform built around microservices, also native multi-arch capable on both ARM and x86. And at that point, people need cheap threads, workload acceleration under the hood, and it's all orchestrated by smart software that abstracts that from the actual infrastructure. I'm not saying virtualization per se, but it will be something that orchestrates it. So.
Very good. And actually, just to close out now, because we're running out of time here, in the last 30 seconds apiece, very quickly, you talked to the future a little bit there, Zach. I'm going to give Elsie and everyone else along the panel here a chance just to give their closing thoughts. So you want to 30 seconds?
That was my closing thought.
Well, you have 30 more seconds then.
All right, 30 more seconds is, what's the coupon code? I don't know. Oh, go to packet.net/Red Hat. You can run Red Hat Enterprise Linux for free on Packet on ARM. Starting from today. So if you guys want to try Red Hat OpenStack, you want to try OpenShift, you want to try native Docker containers with Kubernetes, go to town, right? You guys get free credit for signing up. You can spin up a bunch of ARM servers in a few minutes running Red Hat and see if all of this stuff is myth or reality.
Excellent.
ARM servers is a reality, and you will see it coming soon, very soon.
Larry.
So the innovation that you're going to see from the silicon up the stack is what's going to make this not just a reality, but I think a big momentum shift. We're in early days right now. We're going to reflect back on this as when we both use the term the flywheel gets moving, and I think we're really at that point. So you'll be able to come back and tell your kids or your grandchildren that you were here at this important point.
Remember that. Jeff.
So I'm going back to the nanoservices because I had a little brainwave. We've all seen this movie before, right? It's called Big Hero 5, where they had the little nanobots that self-assemble themselves into suitable combinations and do whatever this guy wants, right? That's what we're going for here. And these guys here, we're the big hero, right? We're here to save you from that limited choice environment, right? So, it's ready. It's reality.
I believe that was rendered on RHEL, so that's great. Martin.
The only thing I would say is, look, all of the work that we do, it's all about collaborative open source development, just as it is in the in the x86 world. And there's a lot of work still to be done, but deploying ARM as a server in a data center you could do today. So,
And last but not least, the marketing guy.
All right. So first of all, thank you for showing up. We really appreciate it. As the last panelist on the panel, I want to take the second and use my time to thank you for being here. Thanks to panelists on behalf of Red Hat and Red Hat Summit. What I'm going to tell you from Red Hat's perspective is that we're going to continue our efforts around eliminating all the myth that comes from the ecosystem and that surrounds ARM. And that's our job, and we have been pretty adamant about that, and we'll continue to stay on course. So when it will be a reality, you'll be the first to know. Thank you.
Thank
And
you.
please stay for the drawing. We have a prize at the end.
I was hoping you'd say that because I just realized I wasn't sure how that happened. So great. Okay. Thank you.